Hello, amazing people, amazing students, and all the lovers of chemistry out there. On this episode of Question for the Day, I'm super excited to be handling this question with you. So let's go into see what it entails and let's see if we can do justice to this bad boy. Now, the question says, what is the molarity of a solution that is prepared by dissolving 5.3 grams of sodium chloride NaCl in enough water to make 250 cm cube of the solution? So let's go ahead and solve this. What they are asking us in this question is simply the molarity of this solution. Now, molarity is defined as the concentration of a solution that is measured in moles per dm cube. Moles per d, many a times people write it like this: mole per dm cube. Okay, so molarity is the concentration of a solution that is measured in moles per dm cube, and the formula for calculating it is actually the number of moles of the solute divided by the volume of the solution, in dm cube, because the unit for measuring molarity is moles per dm cube. So we need to have the volume in dm cube, and then we need to also have the number of moles of the solute. So now let's go ahead and impute our values into this formula. First of all, we need the number of moles of solute. Do we have number of moles of solute? No, we do not. But we know the formula for calculating number of moles. Number of moles, N, is equal to the mass of a substance divided by the molar mass of that substance. The mass of sodium chloride in this case is 5.3 grams. The molar mass of sodium chloride, we don't know it, but we can calculate it using the molecular formula NaCl. NaCl is equal to, the atomic mass of Na is 23 and the atomic mass of chlorine is 35.5. Now, if we add these two together, we have 23 plus 35.5. What we end up having is 58.5. So we have 58.5 grams per mole as the molecular mass of sodium chloride. So let's put it into this formula. Number of moles is equal to 5.3, which is the mass, divided by the molar mass, which is 58.5. If we punch our calculators and we calculate 5.3 divided by 58.5. 5.3 divided by 58.5 gives us 0.091 moles. So now we have the number of moles of the solute to be 0.091. Now we need the volume of the solution in dm cube. They gave us the volume of the solution to be 250 cm cube. So we need to convert this to dm cube. Now, what is the unit for conversion? The unit for conversion is that 1 dm cube makes up 1000 cm cube. So now we want to convert 250 cm cube into dm cube. So we have x on this side. We can cross multiply. When we cross multiply, we have 1000 times x is equal to 250 times 1. So to find x, we just divide both sides by 1000 divided by 1000. X is now equal to 250 divided by 1000. Let's cancel this. 25 here gives us 1, 25 here gives us 4. This is 1 over 4, which is 0.25 dm cube. So now we have the volume of this solution in dm cube, and we have the number of moles of the solute to be 0.091. 0.091 moles. So what is the next thing to do? We just impute it into our formula that says molarity is equal to the number of moles of solute divided by the volume of the solution in DMQ. The number of moles of solute is 0.091 divided by the volume of the solution is 0.25. So if we do a quick math by saying 0.091 divided by 0.25, that gives us 0.364 0.364 moles per dmq, because that is the unit for measuring molarity. So the question says, what is the molarity of a solution prepared by dissolving 5.3 grams of sodium chloride NaCl in enough water to make 250 cm cube of the solution? We have just calculated it to be 0.364 moles per dmq. I'm sure you enjoyed every bit of today's episode of Question for the Day. I'd like you to like this video, subscribe, and turn on the notification bell icon as you wait for more interesting concepts from me. I'll see you in the next one.